properties of metals. Sometimes, physical properties may not give an indication whether the element is a metal or a non-metal. Let us take an example. Graphite is a non-metal but conducts electricity like metals. Iodine is a non-metal but exists as solid crystals having a shiny metallic luster. So, classification of elements on the basis of chemical properties is more accurate. This will become clearer by performing an activity. We hold a piece of magnesium ribbon with a pair of tongs over a flame. What do we observe? We notice that it starts burning with a dazzling light and produces a white powder called magnesium oxide. This means that magnesium reacts with oxygen to form magnesium oxide. Magnesium oxide formed is dissolved in water to form magnesium hydroxide. Now, if we test the solution with a red litmus paper, we will find that red litmus solution turns blue. We infer that the magnesium oxide solution is basic in nature. We take some powdered sulfur in a deflagrating spoon and heat it. When sulfur starts burning, we introduce the spoon into a gas jar containing some water as shown in animation. We then cover the jar with a lid and remove the spoon when sulfur stops burning. We then shake the jar well. We then test the solution with blue litmus paper, which turns it red. Sulfur dioxide solution in water is acidic in nature. From these activities, we infer that metallic oxides are basic in nature, whereas non-metallic oxides are acidic in nature. Chemical properties of metals. Metals possess large atomic size. They have a tendency to lose one or more electrons present in the valence shells of their atoms to form positive ions. After losing the electrons, they achieve the electronic configuration of the nearest noble gas element. In this present case, it is neon, which has the configuration of 2 and 8. Due to this ionization, energies of metals are very low. That is why they possess electropositive character and hence are very reactive chemically. M metal atom gives Mn positive plus Ne negative, where N stands for numerical value. Sodium with electronic configuration of 2, 8 and 1 gives sodium positive ion plus electrons. Magnesium with electronic configuration of 2, 8 and 2 gives Mg2 positive plus 2E negative. And aluminium with electronic configuration of 2, 8, 3 gives Al3 positive plus 3E negative. The chemical properties of metals are mostly linked with the electron-releasing tendency of their atoms. Greater the tendency, more will be the reactivity of the metal. Some of the chemical properties of metals are: reaction of metals with oxygen present in air. Almost all metals except gold, platinum react with oxygen under different conditions to form metallic oxides, which are basic oxides. Metal reacts with oxygen present in air to give metallic oxide. Reaction of highly reactive metals with oxygen. Due to extreme reactivity, sodium and potassium metals are stored in kerosene oil in order to protect them from moisture and oxygen. They are so soft that they can be cut with a piece of knife. Reactive metals like sodium and potassium react with oxygen even at room temperature to form sodium oxide and potassium oxide respectively. Have a look at sodium and sodium oxide. The oxides of sodium and potassium react with water to form soluble sodium hydroxide. The metallic oxides and hydroxides are highly basic in nature. Hence, they turn red litmus into blue. Na2O in solid state reacts with H2O in liquid state to give 2NaOH, which is an aqueous alkali. K2O in solid state reacts with water in liquid state to give 2KOH, which is an aqueous alkali. Reaction of fairly active alkali metal with oxygen. Let us now learn about the reaction of magnesium with oxygen. Magnesium reacts with oxygen to form magnesium oxide. Magnesium wire burns in oxygen with white dazzling light. This reaction occurs at high temperature, and that too in the excess of oxygen. Magnesium oxide formed is quite stable. Magnesium oxide is a basic oxide. The melting point of magnesium oxide is 2800 degrees centigrade. Therefore, it is used as a refractory material. It is used as internal lining of furnaces where heating is done up to very high temperatures. Reaction of aluminium with oxygen. Aluminium, when heated with oxygen, an inert layer of aluminium oxide is formed. This is called corundum. It protects the metal from further attack of oxygen and is called the protective layer of oxide. Corundum is used for the preparation of sandpaper. 4Al reacts with 3O2 to give 2Al2O3, which means aluminium reacts with oxygen to give aluminium oxide or corundum. Have a look at the aluminium metal and its oxide. We will next learn about reaction of zinc with oxygen. Zinc metal, when heated with oxygen, forms zinc oxide. This oxide is amphoteric in nature. Amphoteric oxides are metallic oxides which show both basic as well as acidic properties. When they react with an acid, they produce salt and water showing basic properties. ZnO reacts with 2HCl to give ZnCl2 plus H2O. While reacting with alkalis, they form salts and water showing acidic properties. Example: ZnO reacts with 2NaOH to give Na2ZnO2, that is sodium zincate, and H2O. Magnesium oxide is a basic oxide. Both zinc oxide and aluminium oxide are amphoteric in nature. Reaction of iron with oxygen. Iron is comparatively less reactive. It reacts with oxygen but does not burn. When iron is exposed to moist air for a long time, it undergoes rusting, which can be easily identified by the presence of reddish-brown flaky coating on the surface. 4Fe reacts with 3O2 plus XH2O to give 2Fe2O3 XH2O. This brown-colored hydrated ferric oxide is also known as rust. It is not uniform and does not even stick evenly to surface of iron metal. Due to non-uniform nature, it is unable to protect the inner surface of iron from further reaction with atmospheric oxygen. Have a look at the difference between the corroded and the original product. Reaction of copper with oxygen. Copper metal is even less reactive than iron. Have you observed the green deposit on the surface of copper vessels? When a copper vessel is exposed to moist air for long, it acquires a dull green coating. The green material is a mixture of copper hydroxide, that is CuOH whole twice, and copper carbonate, that is CuCO3. Have a look at the equation which takes place during the reaction. Copper reacts with water, carbon dioxide, and oxygen to form copper hydroxide and copper carbonate. It reacts with oxygen on prolonged heating to form a black mass of copper oxide. Copper oxide is also a basic oxide. It reacts with dilute acids to form salt and water. Reaction of noble metals with oxygen. Let me tell you that silver and gold do not react with oxygen even on prolonged heating because they are non-reactive metals. It is due to this property they are used for making jewelry. These metals retain their shiny luster for a very long time.